So yeah, we can go with that. Now, some people would look at this and say you can simplify with the 4 and 2, and you could. Okay, but again, is it required that you simplify in the beginning or the end? There isn't. So right here, let's just stick with that then. So we'll just multiply the numerators and denominators. So that'd be 1 times 4 in the numerators. 1 times 4 is 4. And then in the denominator, you got 2 times 5, which is 10. Now, even at this point, the math is good, right? 2 times 5 is 10, 1 times 4 is 4. But a common mistake we get at this point is where students are like, you know what, I'm just going to keep it like that. Whenever you get an answer for any type of fractional problem, always look to see if it can be simplified. So how would we simplify this? Yeah, since both of them are even, at least they're divisible by 2. Could they be divisible by more? Perhaps, but let's just stick with that. So I'd say 4, I know I can divide it by 2, but 10 also should be divisible by 2. So 4 divided by 2, that goes back to our multiplication tables, right? 4 divided by 2 is 2, and 10 divided by 2 is 5. Now at this point, we have 2/5. Is that simplifiable? Very good. This is not simplifiable. They're not, neither 2 or 5 are divisible by the same thing other than 1, which doesn't really affect it. So we'll keep it like this. 2/5 would be our simplified answer. And you have gotten the same answer if you had simplified 4 and 2 by dividing them by 2 as well. We need to be able to force denominators to match. Now, that may not make sense right now, but we'll get to it, okay? And then after that, we should be able to add the fractions, but it pretty much is in that order as well. You have to make the denominators match, and then we'll add the fractions. So this is a pretty nerdy way to say, let's add fractions right here. Like we've seen before, though, this is abstract, so we're just using letters, but the letters would represent numbers. But you'll notice right here that the denominators, the bottom number here, matches, right? Okay, well, let's go back with fractions and just think, what does the bottom number tell us? So if we compare this to a pizza, that's not bad. The electronics can draw stuff really good. So let's say that, let's just do something fairly easy. It can be a smaller pizza. Let's just cut this in half, okay? Now, let's say that, we've talked about this already, but let's say that this purple piece is your piece, okay? So as a fraction, how many pieces of this pizza do you get? Okay, you're a little ahead of me there. Yeah, but yeah, you get 1 piece. You get that 1 purple piece. And then how many pieces of pizza are there to make this pizza? 2, right? So let's say there's 1 piece out of 2 pieces. So if I were to cut this pizza here, did I change the size of the pizza? No, but what did change? So if I were to keep this way, I would get an equivalent fraction, which we talked about already. But now, instead of you getting 1 piece out of 2, now you're getting 2 pieces out of 4, right? So we didn't really change how much pizza you get. We just changed how many pieces you get and then how big the pieces are. So we can do that with the fractions. We'll use the example for that. So I'll get to that. But no matter what, just like we did with multiplication and division, whenever you get to the end, always check your work, check your answer especially, and just see if it can be simplified. Because if it can, then you're going to need to. If you don't simplify it on the assignment or on a test or a quiz or something like that, then you lose points because it needs to be fully simplified. But yeah, to do that, we'll go through divisibility rules. And like I said, like we saw on the bell work, I said bell work, that's at school, but on our starter problem, you can do that at the end or you can do it at the beginning as well. It doesn't really matter. So as long as you've done all the simplification that you can, then you should be good to go. So let's take these and let's show why this works. Okay, so this one, remember, it is imperative when you add and subtract your fractions that the denominators match. Well, these ones already match. It's very generous, and we'll see this on the assignment as well. They will already match for us in some cases. That's great. But why do they have to match? So let's go back to to our pizza example. Okay, so this is like saying here we got 2 pizzas. Like this. So based on these fractions, how many pieces are there in each pizza? 4 tells us that there should be 4 pieces of pizza for each pizza. So I'm going to split this. You guys probably can cut this better than I can. That's okay. I've done worse. Now the first pizza, we're going to use this fraction. We got 2/4. Okay, so this fraction right here is 2 pieces of pizza out of the 4. So I'm just going to highlight 2 of those pieces. Okay, so there's that one. Then the next one's going to have 3 pieces. Now, you may be highlighting different pieces as well, as long as there's 3 and 2. Okay, so that's not too bad. So we got these 3 pieces that are purple. That comes from our second fraction. Now, since we're looking at pizza right here, we're adding these 2 together. What does this mean in terms of the pizzas? All right, so we've taken this piece right here and we put it over here. But you notice as well, let's see if I can do that. It's not great, but it'll work. So we've made now a full piece pizza on this one. And then what do we have left? We have this extra piece. Now, in fourths, if you were to look at this, we added them together. How many fourths is that? So, yeah, how many pieces of pizza do we have left in fourths? Well, you got 1, 2, 3, 4, and 5. 5 pieces of pizza. This fraction is telling us you got 5 pieces of pizza left, and they are 4th size pieces. All right, well, that was fun. And we all like pizza because, you can make it savory or sweet. But how does that relate to this right here, up here back at the math? Because the modeling is great. Like, I like the modeling. It's pretty. And I'm math nerdy about it, so, I geek out about it. But let's go back to what we were saying in the last slide. So let's take these 2 fractions. Now remember, the denominator tells us the sizes of the pieces, they are the same. So we're adding fourths together. I know that we're going to be adding these together, okay, but how many pieces are there? Well, you have 2 of the fourths, and then you got 3 of the fourths that you're combining. And so how many fourths do you have? Well, just like we found below, 5 fourths. Now that we have this, the denominators are the same. I'm going to show this step in between as part of my work. So I know that I'm adding 7s from the denominators. That's the sizes of my pieces, so they're going to stay the same size for me. And we're going to add the numerators. That's how many pieces we have. So we had 3 pieces and 6 pieces, which when I do add them together, in 7th size pieces, that would be 9. If we were to take this example, we can divide both the 22 and the 11 by 11, and that would give us 2/1. Now, is 2/1 considered fully simplified? Yeah. To be considered fully simplified, again, it's not changing the value overall, but it's kind of like math people. We just hate writing. I've talked about this before, kind of like exponents and counting changes to addition, but something like this, it's not fully simplified because we can make it less writing. It's kind of how that comes out right there, okay? So even though it is exactly the same value, just like this one was exactly the same value, it's not fully simplified, but this also is not simplified because anything divided by 1 is itself. So we've seen this part already. You have to have common denominators. You must have common denominators before you can start adding the numerators together. Of course, we never add the denominators, though it is a very common mistake, which we hope that you will avoid because it tells you the sizes of the pieces. But what we're going to have to do is we're going to have to make the denominators match because the last few problems, hey, that's pretty good. The denominators match, so the sizes of the pieces are all the same. If you got 2 pizzas in a box and they're the same size pieces, you can combine them and kind of figure that out pretty quick. But if they do not match, then what we have to do is add cuts to our pizza. So for example, let's go back to a pizza again. It's supposed to be a pretty good circle. So let's say that we got fourths, okay? But let's say that we're trying to make this in eighths. So what do? Yeah, you're gonna add 2 more cuts, right? So you're gonna cut right here. That was meant to go through the middle, by the way. And then we could add a cut right there. Now there's eight pieces. Now, again, we haven't changed the size of the pizza, but we did change the size of the pieces, right? And that's okay. You can make more cuts in your pizza if you need to. But in doing so, by changing the sizes of the pieces, again, we want to do this with purpose. So if, let's say that one of the fractions, like we started out, maybe it was in fourths, but what we want to do is write some kind of equivalent fraction in eighths. Okay, you can do that, all right? In fact, if we wanted to emphasize this, maybe you start with how much pizza you had before. So before you had 2 pieces out of 4, but now that we've made 2 extra cuts to make 8 pieces, now you have 4 pieces of pizza. Is that okay? Absolutely. You still get the exact same amount of pizza, so this is still the same amount. So they are still equivalent, but all we've done is change the sizes of the pizza pieces. Forcing common denominators. So this is going back to 2.1, common multiples. You guys remember that and how fun it was, right? So you have 2 methods for finding a common multiple. You can just list it, or you can use prime factors, okay? Now, all we're doing is scaling the individual fractions accordingly, meaning we're going to force the sizes of the pieces to match. And once we get that, then we can operate. Now, notice this is saying just perform the operation. This is good for both addition and subtraction. So this is getting also a little bit into 2.11 as well. And then always at the very end, we should always check to make sure that our answer cannot be simplified. Because if it can, then we should. So with that, there will be times where they're like, you need the lowest common denominator. Fair enough. But if it doesn't ask, here's the good news for us, is this process is great. Finding a lowest common multiple is fun. But the truth is we don't need actually the lowest common multiple in order to add or subtract our fractions. Because what are we just trying to do? All we're trying to do is get the denominators to match. And our two strategies are you can list multiples until you find one that matches, or even the lowest common one that matches. That would be good for lowest common multiple. Or you can use prime factorization. Find the lowest common denominator on this one. Just so you understand, on these problems, we're not operating here, right? So actually, and I just did this because it's going to show this on the assignment, we don't need those numerators right there. So you can pretty much ignore them, okay? So what's the lowest common denominator that we can use? Well, we got 2 strategies. You can list values. So I can start with the 8. So if I had 8, you can just add another 8 there. And if you use fingers or really, I hope by now you guys have the multiplication table memorized, but I'm going to assume maybe you don't. So 8 plus 8 is going to give you 16. And then you can add another 8 there to get 24. You can add another 8 to get 32. Plus another 8 is 40. Plus another 8 is 48. Another 8 will give you 56. So yeah, or you can multiply. That would have been 8 times 7. 8 times 9 would be 63. I did that. That's not what I meant. 8 times 8 is 64. 8 times 9 is 72. And then 8 times 10 would be 80. Now I'm going to stop there. Is there going to be a common multiple up to 80? Because I've got the first 10 multiples of 8, right? Which is really just from our multiplication table. Maybe, maybe not. Let's go to 15. So we do not have our 15 multiplication tables memorized. So I'm going to use addition on this one. So 15, that'll be my first multiple. I'll put a check next to it. Plus another 15 will be 30. Plus another 15. I'm skipping a little bit of the math. Hopefully that's okay. 0 plus 5 is 5. 3 plus 1 is 4. So there's my third multiple. Is there any matches? Nope, they're close, but we're not there yet. So we're going to add another 15. 10, carry the 1, 60. Yeah, still no matches. plus another 15 will be 75. Yep, still no matches. Plus another 15 will be 90. So I've passed the 80. So I'm just going to keep going with the 15. I feel like I'm on a roll there. Plus another 15, 105. Plus another 15 will be 10, carry the 1, 2, 120. Plus another 15 will be 135. Okay, I'll stop there. Let's see what happens with the 8s. So 80. We got 8. That would have been 8 times 10. 8 times 11 would be 88. 8 times 12 would be 96. So still no matches. Now at this point, since we don't have anything beyond that memorized, we'll have to add 8 there. And so that'd be 104. Then I'd have to add another 8 to get 112. And then I ran out of space. So 112 plus another 8, going to be 120. Boom. All right, now I have matching multiples of both 8 and 15. Now, this is just an exercise that we've gone over already in 2.1, where we're like, you know what, just list these and then find your common multiple, right? In fact, 120 happens to be the lowest common multiple for both of these, which is also what it's asking for, lowest common denominator. So the lowest common denominator for us on this one is 120. Now that's one method for finding a lowest common multiple. Some students are okay with the addition, like, you know, you get down to your 12th multiple down here, and then just start adding if you need to. Or if it's an uncommon value that we don't know the multiples of, then we just have to add all the way down. Some students don't like that, which is fine, because you can, to find a lowest common multiple or lowest common denominator, you can use prime factorization. So prime factorization means that we're going to be looking for all the prime factors of both values. So that'd be 8. Now factors means we're looking for multiplication, numbers that we multiply together to get 8. So what numbers multiplied to give us 8? Okay, so the 2 is prime, so I put it in my list. But 4 can be split up as well into 2 and 2. Very good. And those are both prime as well. So we got 8 is 2 times 2 times 2. Now we'll go to 15. I was using green there, huh? Okay, what 2 numbers multiply to give us 15? And both 3 and 5 are prime. So we circle those in, and we got 15. Instead of writing it as 15, I'm going to show it as prime factorization, which would be 3 times 5. Now in this process, we would usually look for any common multiples, or common factors rather in this case, of 8 and 15, but there are none. No common factors. So we got to take all the uncommon factors and multiply those. Okay, so my uncommon factors, actually all of them are uncommon, right, between the 2 numbers. So even though 2 is common with 8, it's within the same value, so we can't include those. So they're still considered uncommon factors. You got 2 times 2 times 2, which we know is 8, by the way. So we've already done that. And then we have also the other uncommon factors of 3 and 5. Once we multiply these, then we will have our lowest common denominator. Now, if you do multiply these, I'm going to skip some work here. Guess what number you're going to get? Yeah, we already found it here and here, right? It's 120. So 120 is our lowest common multiple, which would produce a lowest common denominator. But just so we understand as well, so let's go back to the original fractions right here. This is scaling the whole fraction. This is what we're trying to do, is force these 2 denominators to match so that if there were an operation between these, such as addition or subtraction, right now just addition, that we could combine the numerators together, add them together. But since they don't match, what you'd have to do is you'd have to figure out like 8 right here. What did we have to multiply 8 by to get 120? You could count those multiples as the 15th multiple. So you'd say you'd have to do 8 times 15, and then also you'd have to do 12 times 15. I'm not going to worry about that work right now. I'm just showing you what's coming, right? And that's what you'd multiply 8 by to get the common denominator of 120. But you'd have to do the same thing with 15. You'd have to say, well, 15, I'd have to multiply that by 8 because 120 was the 8th multiple of 15. So if you do it to the denominator, what we've done in the past also, you have to do it to the numerator. Doing that to the numerator and denominator together will not change the overall value of the fraction, but it will change the way it looks. And in this case, it will produce a common denominator for us. So we got our multiples of 9 here. And I'm still going to go back and use the prime factorization for that. But that means since 9 is our lowest common multiple between the two fractions, I can keep the first fraction the same, even though it could be simplified, okay? All right, so 9, which multiple of 3 is 9? Well, that's a 1, 2, 3. It's the third multiple of 3. So that means I would have to take the 3 and multiply it by 3 to get a common denominator of 9. Now remember, we're scaling the fraction, so I need something that's equivalent to 1/3, but with a denominator of 9, which means I'll have to multiply the numerator as well. So 1 times 3 is going to give me 3/9 right there. So what we've done right there, multiplying by 3, is we've now forced the sizes of the pieces, at least in the second pizza, we'll call it pizza, to be the same size, 9th. And that's great, because now that they're the same size, I can take the number of pieces and just add those together because the sizes are 9ths. Well, we had 6 of those 9th size pieces and then 3 of them as well. And 6 plus 3 is 9. So overall, between these two, again, we're going to call them pizzas, 9 divided by 9, anything divided by itself is 1. You could have just done, well, 9 divided by 9 is 1, and 9 divided by 9 is 1. You would have got 1 over 1, which still should be fully simplified into a 1. Because anything divided by 1 is itself, including 1. So on this one, I used, I just listed the multiples for that last one. So this one I'll do prime factorization, okay? So let's look at 12, because 60 is going to be our lowest common denominator. So 12 is going to split up between, I'd say, probably 2 and 6. Some people would say 3 and 4, and that's fine as well, because 6 splits up between 3 and 2. So we end up with the same prime factors anyways. So I'm going to rewrite 12 as its factors, prime factors of 2 times 3 times 2. Okay, well, how about 5? Well, 5 is already prime, so it's its own prime factor. And remember, we don't include 1 because 1's not prime. It's not composite either. So 5 is just 5. And again, on this one as well, there are no common factors to use here to find our lowest common multiple, which is going to be our lowest common denominator. So we just take all these values and we just multiply them. 2 times 3 times 2 times 5, which is really just 12 times 5. And that will give you 60. So we're going to force these denominators to be a denominator of 60. I'm going to write these in right now, which you don't have to do. You can wait. Since we're forcing the sizes to be 60th size pieces, how did we get these 60s? Well, down here we can see I had to do 12 to make it a 60. I really just multiplied it by 5 down here, okay? So that would have been 12 times the 5. Now again, if you do it to the denominator, you're going to have to do it to the numerator as well. So the numerator would be 7 times 5, which is 35. And then the 5, yeah, we would have multiplied that by 12 to get 60. So we'll have to do 8 times 12 as well. If you need to stack and multiply that, that's fine. But it should be one of our multiplication facts that we have memorized is 96. Well, let's continue then. So the sizes of the pieces are 60th size pieces. And we're going to add the numerators. That's how many pieces we have. So we have 35 pieces. And we got 96. So if you can do that in your head, that's great. I can't. So I'm going to stack and add these. 35 plus 96. Okay, so in the ones place value, 5 plus 6, 5, 6, 7, 8, 9, 10, 11. So there's 11. Carry the 1 into the tens, the 10 in the tens. Now 1 plus 3, 1, 2, 3, 4, and then plus another 9, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 131. So we end up with 131 pieces that are 60th size pieces. Can that be simplified? Let's go through our divisibility rules. I know 131 is not divisible by 2. So 131 is not divisible by 3, even though 60 is. 60 is also divisible by 5. Is 131 divisible by 5? No, and that, again, just like 2, divisibility by 2, it's a visual check, right? Just look at the ones place value. The one right here means that it's not divisible by 5 either. So we could think of maybe the funky ones, but 60 isn't really related to any of the funky ones like 7 or 11 or 13 or 17. So, yeah, 131, it could even be prime. I don't know for sure if that's the case, but it does not look like it's divisible by anything that 60 is. So it looks like we've simplified it all the way. So, actually, this one ended up being our third strategy. So if you ever want common denominators and you just want them to be common, you don't care if they're lowest common, is you can take the two fractions. So we had 7/12 and plus 8/5. And you can force denominators to match. It's just they're not the lowest common denominator. Now some students, they say, well, then you'll have to simplify in the end. It could be true, but sometimes you won't have to simplify in the end. Okay, because sometimes by using this strategy, you end up with the lowest common denominator anyways, which is what we had in this problem. So what you do is you take the first denominator, which in this case is 12, and you simply multiply it into the second fraction, both numerator and denominator, like this, okay? Now this is kind of, I don't know, I wouldn't say it's commutative property, but we're just making the same thing multiplied by the other thing, okay, which should always produce the same product. So for the second fraction then, what do we get? Well, you'd have a fraction plus another fraction, and then, yeah, we got 5 times 12, which is 60, and then we've already done 8 times 12, which is 96, right? So we ended up with the same fractions here. Okay, now that's taking the first denominator and multiplying it into the other fraction. But then you take the second denominator, 5 here, and multiply it into the first fraction. And what this does at the bottom here is it forces the multiplication to be exactly the same. So since the multiplication is exactly the same, you will automatically get a denominator that is also the same. So this method will always produce common denominators, although they may not always be the lowest common denominator. This problem, it did produce the lowest common denominator, which we had, which was 60. And then you add here to get the 131 over 60. So in the end, you should always check, just like we did up here, and especially if you use this method, always check to make sure your answer cannot be simplified. Sometimes it will, but in this case, it just happened to be that it didn't. That's all right too. On this one, we got 4 plus 7/13. Now, I'm going to do it 3 ways, but hopefully they become more pleasant the more I do it. Now, we need to go back and remember, if we see a whole value like we do 4 right here, we need to see it as a fraction so that we can operate like we do with fractions. So we have to make it over 1. All right? If you ever see a whole value, just make it over 1. And the good news is when we have a 1 denominator, it is very easy to get a 1 to match another denominator, no matter what it is. Which is why I was happy that we chose 13 for this problem, because at this point, let's make this a little bigger, I can take that 1 and I can simply multiply it by 13 in order to get it to match the other 13. So now my new fraction, it will have a denominator of 13. And that also means that the second fraction, I don't have to do anything to it. I can just keep it in 13ths. But my new fraction, again, it's the same value, but it's going to have a different denominator. It's 13. But if I do it to the denominator, I've got to do it to the numerator as well. So 13 times 4, I'll stack and multiply that. So 3 times 4 would be 12, carry the 1. 4 times 1 is 4, but add the 1 makes that 5. So 52, 13. So let's go ahead and do that. We got 13th size pieces, so we'll keep this in 13ths. And we're going to take 52 of them. And we're going to add 7 of them. Okay, so in 13th size pieces, how many is that? 59. So that's what I got, 59 13ths. Okay, so is 59 a multiple of 13? Without doing the math, it is not. In fact, it's not really necessarily close either, but fairly close, I guess. Some students would look at this and be like, well, it's got a 9, so, and this has got a 3, so they're both divisible by 3. No, it doesn't matter if they're divisible by 3, it's got to be divisible by 13. So this would be our improper fraction right here, okay? I said I'd do it 3 times. I guess I'm going to do it twice. Let's go back to the original problem right here, 4 plus 7/13. I'm pointing this out because we're going to see this on the assignment. But this goes back to, I think it was like 2.2, maybe 2.3 stuff. This right here is mixed number format, meaning that you could have just written this as 4 7/13 and been done. Okay, so you can try this as well. 4 times, you could use cycle method here. 4 times 13, which we know is 52. 52 plus a 7, 59. 59 13ths. So just be aware, and the assignment will accept the mixed number. So if you just want to write this as 4 plus 7/13, you can. Okay? But if you want to, I purposely did this not to be a jerk, but just to show you, just to remind you that this is mixed number format, so you can take a bit of a shortcut if you remember that, right? You're going to see addition with 3 fractions, which we're going to have to do. When you do this, my recommendation is that you completely ignore that last fraction. So work from left to right and do 2 at a time. This is going to simplify it. Hopefully it'll simplify it a little bit for us. Okay, so we're going to look at just the 1/2 plus the 2/3 down here. And I need common denominators. Now 2 and 3 isn't too bad, but here's the thing, is I like that last method we used. So what I'm going to do is I'm going to take the 2 denominator and multiply it into the second fraction, denominator and numerator, and that will give me a new same valued fraction, but the denominator is going to match the other denominator. 3 times 2 is 6 in the denominator. In the numerator, 2 times 2 is 4. And then in the numerator would have, again, I take that second 3 denominator and multiply it into the first fraction here. But if I do it to the denominator, I've got to do it to the numerator. So 3 times 2, again, we were planning on this being a 6 because we had already found a 6 right there. But the numerator, 3 times 1 is going to be 3. Now that we have that, we have 6 size pieces, which we're adding. And we just got to take the 2 numerators of 3 and 4 and add those together. So again, we're still dealing in sixths, but 3 plus 4 is going to be 7. Okay, so here's what I got. Let's go back to the original problem up here in the top left. 1/2 plus 2/3. We already know when we combine these, we get 7/6. Now we'll look at the second fraction, which was 3/4, and we'll add that into the 7/6. Okay, so I'm gonna keep using the same method, but I'm gonna show right here, this is not going to be the lowest common denominator. I don't care that it's lowest. I really don't care. I'm just gonna take my 6 denominator and multiply it into the second fraction. Okay, both denominator and numerator, and this will produce a new fraction, but it should be a good common denominator. 4 times 6 is gonna be 24. In the denominator. In the numerator, 3 times 6 is 18. Okay, now I'm going to take the second denominator, 4, and multiply it into the first fraction, denominator and numerator. So again, in the denominator, 4 times 6 is 24, and then in the numerator, 4 times 7 is 28. Now, for those of you that noticed, 28 and 24 and 18 24ths also, these are both simplifiable. So you could simplify those. If you wanted to find the lowest common denominator, you would have used 12ths. I just don't care if it's the lowest common denominator. I can simplify in the end if I need to. So when I add these together, I should end up with 24ths. So we have 28 plus 18. So I'll have to stack and add those. I'll do the work down below. 28 plus 18. Okay, so on the ones place value, 8 plus 8 is 16. There's our 6 in the ones, carry the 110. 1 plus 2 is 3, plus 1 is 4. 46. So this ends up being 46 24ths. Now this is what I was saying before, is some students say, I don't really like this method because in the end, I do have some simplification to perform at this point. It's just, to me, I don't really view it as like super difficult simplification. So let's take 24. I'm sorry, 46. Is I need to look at 46 and 24. You can use long division, but actually this is going to be easier to simplify this first. So 46 and 24 are both divisible by what? 6 and 4 in the ones place value. They're both divisible by 2. So let's divide them both by 2. Now 24 divided by 2 is one of our multiplication facts that we should have memorized. That's 12. 46 divided by 2, though, maybe not so much. So we'll do long division. 46 divided by 2. So 2 goes in a 4 2 times. 2 times 2 is 4. Nothing left over there, so we'll drop the 6. 2 goes in a 6 3 times. 3 times 2 is 6. So we used up everything. Nothing remaining, but our quotient there being 23 is our new numerator. Okay, so we have 23 twelfths. Yeah, that is not simplifiable anymore. 23 is not a multiple of 12. It's not divisible by 2, 3, 4, or 6. So it looks like we have actually simplified this completely. Which, if you wanted to change this into a mixed number, you could. You could use long division. I'm going to skip the math there, but it should be 1 and 11 twelfths, if you want it. So I'm going to use the same method on this one that we did on the last one, right? We got this denominator 6. I'm just going to multiply by 14, but if I do it to the denominator, I've got to do it to the numerator as well. So this will produce a new fraction. And 14 times 6, so 6 times 4 is 24, carry the 2. 6 times 1 is 6, but add the 2 makes that 80. 8 and 4, 84. That's what I meant to say. 9 times 6, though, is 54. 54. Okay, and then I take the 14 denominator and I multiply it into the other fraction as well, so 6 times 14. The good news is we've already done 6 times 14. We already know that's 84. And then the numerator also, multiplied by 14, would be 14. Now we have 84ths, which we're adding the numerators of 14 and also 54. I'm assuming this is not the lowest common denominator. It looks like we're going to have some simplification at the end. That's okay as well. So we're still going to be in 84ths, but we're going to take the 14 and the 54 and add those. So I get 68 on that. Okay, I thought maybe they're divisible by 4, but it doesn't look like they are. So both of these, I know they're divisible by 2. I'm going to skip the long division on that, though, just for the sake of time. So 84 divided by 2 should be 42, and 68 divided by 2 would be 34. Oh, looks like they were divisible by 4. Okay, whatever. So more simplification then, no problem. Yeah, so 34 divided by 2. Again, I'm going to skip the long division here. Hopefully that's okay. But that'll be 17 and 21. Yeah, that's good. That's fully simplified now. That's 2.10 right here, adding fractions. Now, the truth is, if you feel good about adding the fractions, like that process, right? We got to have common denominators. You combine the numerators and then simplify at the end. However you're finding your common denominators is up to you. But if you feel good about that process, the truth is that subtraction is going to be almost exactly the same.